Welcome to a video which is suitable for our low remove students, and it looks at fuels and what makes a good fuel and how fuels burn, and it also looks at ethanol production, and I suspect that will be in the second half of the video, which will be on a separate YouTube link. So before we start, I think it would be worth looking at actually what makes a good fuel. Now that's quite a tricky question to answer because it depends what the fuel is being used for. You have to take into account all kinds of things to do with transportation of the fuel and storage and how quickly you want the fuel to burn. But essentially, a good fuel is a substance that burns readily to release energy. And in our lives, we come across a huge number of fuels. Now, a number of these are from a family of compounds called hydrocarbons. So natural gas, for example, which heats my home. I've got a boiler in the bathroom, and that runs on natural gas. I've got a hob in the kitchen on which I do my cooking. That also runs on natural gas. Now, natural gas contains methane, which is CH4. And that's an example of a hydrocarbon. So CH4 is an example of a hydrocarbon. When I go camping in the summer, my fuel, which I use on the stove when I cook, is propane. And you don't need to know this, but propane has the formula C3H8. And that's another example of a hydrocarbon. And you need to know what the definition of a hydrocarbon is, and that is, it's a compound that only contains carbon and hydrogen. So those are the only constituents within your compound. Now, ethanol is also a very good fuel. And on the IGCSE course, we look at two methods of producing ethanol. And the formula of ethanol is C2H5OH. And some people actually shorten that a little bit down to C2H6O. Now, both of these are acceptable. But hopefully at this point you're linking the formula of ethanol to this term up here, hydrocarbon. Is ethanol a hydrocarbon? And of course the answer is no. And the reason it is not a hydrocarbon is because ethanol contains oxygen. So we're going to look now at what happens when hydrocarbons burn. So if there is sufficient oxygen in the reaction where we are combusting a hydrocarbon fuel, you will get complete combustion. Now, to get complete combustion, you need a really good supply of oxygen. And if we use methane as an example, we'll have methane plus oxygen in our equation. And you might think, well, what are the products of that reaction going to be? And it's a little bit easier to work out if I give you the formula of the reactants. So here we've got methane, which is CH4, and here we've got oxygen. And in the reaction, the carbon combines with the oxygen and hydrogen combines with the oxygen as well. So what we produce when the carbon combines with the oxygen, we make CO2. And when the hydrogen combines with the oxygen, we make H2O, which is going to be a liquid. Now the equation needs balancing because you can see we've got 4 hydrogens over here and only 2 over there. So let's even that up by putting a big 2 here in front of the H2O, and that means we've now got 4 oxygens over here and only 2 on this side. So let's even that up by putting a 2 in there. I think we should complete the word equation as well as the symbol equation. So methane plus oxygen gives carbon dioxide and water. it's important that if you're asked in an exam to write a word equation, you don't put a few symbols in the word equation. So this is a word equation, this is a symbol equation. It's not okay to mix the two together, even if you're feeling short of time and you haven't got the time to write water. You can't write H2O in a word equation. Now, you might have seen an experiment to test whether this actually happens or not. So here we have a diagram showing the experiment we would use, and you can see that we're burning a tea light or a night light. Now this is made of wax, okay, and wax contains hydrocarbons. And as the wax is burning, the gases that are released are dragged up through this system by a pump. So anything which is being produced passes by cobalt chloride paper and passes through lime water. Now, I'm pretty sure that most of you will know that lime water is a test for carbon dioxide. So one would expect a white precipitate to form in the lime water. In other words, the lime water goes cloudy. Okay, now I must admit I prefer to say that a white precipitate forms, referring to the white solid which makes it cloudy, but in terms of your exam you can get away with saying goes cloudy. I'm hoping that you know that cobalt chloride paper is a test for water. And if water is present, the cobalt chloride paper goes from blue, I'm not quite sure why something's appearing on my screen, but blue to pink. Now, you might not use cobalt chloride paper. Instead of using cobalt chloride paper, we could also use anhydrous copper sulfate. So if we use anhydrous copper sulfate, which is a white solid, and put that in the bottom of this boiling tube here, so if we fill that up with a white powder, anhydrous copper sulfate, that will go from white to blue, showing that water is present. Now that only happens if you've got complete combustion. Let's look at what happens if not sufficient or if insufficient oxygen is present. So if there's a lack of oxygen, you'll still get a combustion reaction, but it won't go to completion, which is a bad thing. You don't produce as much energy as you would hope, therefore you need to use more fuel, and that's obviously a waste. So if we've got methane plus oxygen, and that was CH4, I apologise for the scruffy handwriting and using a very awkward stylus. Now, last time, the oxygen combined with the hydrogen to make water, and that happens again. You make H2O. But, unfortunately, there's not enough oxygen to combine with carbon to make carbon dioxide. So this time, you make carbon monoxide. So up here we'll put water, and up here we'll put carbon monoxide. And again we need to balance, and I'm going to do this quite quickly because I'm running short of time on the video. So I'm going to put a 2 there to a 4 here. So we've now got 8 hydrogens, so I'll put a 2 there. And now let's count up our oxygens. I've got 4, 2 makes 6, so I'll put a 3 here. Now, sometimes you also, instead of getting carbon monoxide, or maybe as well as getting carbon monoxide, you might get a bit of soot coming off, a little bit of carbon. So that's something to bear in mind, and I'll give you a clue about that in the exam question. Now, I've already said that that's a problem because the fuel burns inefficiently and you don't produce enough energy, so you need to burn more fuel. What a waste. But it's also a problem because carbon monoxide is toxic, and the examiners absolutely love to ask about this. It's a problem because it's toxic, And what happens is when a human breathes in carbon monoxide, it's absorbed into the bloodstream and it binds very strongly to hemoglobin. Now, hemoglobin is used to transport oxygen around the body, and the oxygen binds quite weakly to the hemoglobin, so it can be released at points in the body where it is needed. Sadly, if the carbon monoxide has bonded to the hemoglobin, the oxygen can't get on. The hemoglobin is stuck to the carbon monoxide is stuck to the hemoglobin where the oxygen would have gone. So the body can no longer transport oxygen, so effectively you suffocate, which is absolutely terrible. And so if you've got a gas fire in the house, or a gas heater, or a boiler, or a gas cooker, you're advised to have a carbon monoxide detector near it just to check if any carbon monoxide is being produced. One of my most exciting Christmas presents was a carbon monoxide detector from my mother, who was very concerned about the gas hob in my kitchen. So the final, I digress. The final point on here is that the carbon monoxide binds very strongly to the hemoglobin, and it prevents oxygen being transported. My writing's getting even worse in the body. And I think that's about it for the first half of the video.